Hi there, and welcome to this edition for LinkedIn Live. And we're going to be talking today about data architecture. OMG, it's all about people. And if you look there, we have a very clever reference to Soylent Green. If you're not familiar with that, you will be by the end of this webinar. But before we get to that, I'd actually like to go ahead and introduce the star of this show for today. So let's go to the next slide here, and let's hear it from the horse's mouth, so to speak. Mark, or I should say the man, the myth, the Mark. Looks like you've kind of been around a little bit. True statement?
I think that's a fair assessment. It's the kind way of saying you're old.
We won't say that at all, but I'm duly impressed by your credentials. I've heard of Carnegie Mellon. Very, very appropriate. But what I want to do today is kind of talk about data architecture. So if we kind of flip to the next slide, one of the questions I would kind of ask, because this is what you study, is, well, why this topic? I mean, what's so interesting about data?
Data's not interesting. It's the architecture that's interesting, right? So, yeah, we talk a lot about data work, and we keep talking about data and tech, and we forget that we're doing all of this stuff either to enable people, or that people want applications that do things with data. And it always boils back down to making it easier for organizations to use information, or for people to use information. So the foundational element is data architecture, and underneath that, it's people.
Oh my goodness. So, kind of the first question that I would have, I think a lot of people have, is if you look at the next slide, it's like, well, what is data architecture? Because I've always, when somebody said data architecture, I thought, oh, okay, so it's a data model. But, maybe it's not the model. Maybe it's something else. Is this kind of what you see out there? Is this what people tell you data architecture is?
Yeah, I hear lots of different things. Speaking at conferences a lot, I sit through other people's talks when I'm not speaking, or now it's online, but same thing. And depending on who you're talking to, you'll hear something completely different, right? If you talk to a cloud architect, for example, you hear data storage all the time, right? And the data architecture diagram that you look at will be a bunch of boxes that are like, well, here's S3 and that's HDFS, and here's a relational database, and maybe an arrow going between them. And that's an element of data architecture. That's part of its implementation of where you've chosen to put things, but it doesn't really mean that that's what it is. And then data models, that's what you get when you talk to data architects with that title, or DBAs, or people who worked in data warehouses and databases. And the data architecture is all in the abstract logical layer, not the physical storage layer, because you don't need to worry about any of that with a database. And so, it's an element, it's how you're structuring it, but that's not the entirety of a data architecture. And then there's the technology view, which is, go to the tech and developer oriented conferences, or more dominant now in the cloud conferences too, is this tool or that tool, or this, new technology that stores this or indexes that. And so you get an architecture diagram that is a bunch of product names or technology labels with arrows between them, and the arrows are the data, right? There is no data in that version of architecture, which I find kind of interesting.
Okay, so kind of like what the title says, then data architecture is actually made of the people. So on the next slide then is kind of what you're telling me is really making up data architecture.
Right. It's abstract. I mean, architecture is an abstraction. It's not the implementation. It's the description of how you implement it and what that implementation might be, or how you constrain it, right? So, the formal definition is really processes, standards, and policies, which sounds really boring, but that's the fundamental nature of what it is that you do as an architect. You make trade-off decisions based on constraints. Constraints have to come from somewhere. Some of it's technology, some of it's data, most of it's what people need to do. And so you have to be able to answer these questions about your data architecture. What do you get? What kind of information do people want is the origin of what data you should be managing in the first place, as opposed to, hey, look, I've got a system, let's collect data. It's kind of a silly way of going about things. And then there's the, where do you keep it and why do you keep it there, right? Which is part of some of the storage and data modeling bits. And then how do you organize it? So that is really the fundamental questions that a data architecture or a data architect person should be thinking about and answering. And if you can't answer those questions, all of which originate with people, then you've got a bit of a problem.
So again, to kind of emphasize, the data architecture is how we're going to collect it, why we're going to do it, but it's not the actual implementation, because that's honestly, I think data architecture, great, this is an integer, that's a varchar, and I start going to town, you're saying, no, that's not it.
Right. It's much more abstract than that.
Okay. So then how do I start getting there? So if I kind of go to the next slide, it sounds like I'm not just going to start running out and cataloging all of the data that's in my system.
Right. It takes some thought about organization, right? Data architecture is all about not just organizing the information, right? That's kind of the backroom view of a library, right? The backroom of a library has all kinds of piles of books and catalogs and all sorts of other things, but it's where people meet the information, or where the application that you're building that's going to use the data meets the data. And that takes organization and it takes methods. The real question is, how do you organize these things? Which I think we kind of hit on the next slide.
Okay. So, as we're kind of looking at the next slide, one of the things I want to point out is normally I like to chat about the cloud, but it sounds like this is not specific to cloud. This actually transcends any sort of implementation model.
Yeah. I mean, there's organizing principles that have to sit underneath these things, and they're irrespective of where you do it, or to some extent, what it is you're using to do it. When you think about a library and organizing books, it's done a certain way. It's done, if you were to focus at home on doing I'm going to organize my books by color, then, you're taking the kind of approach that in the technical world you hear as data first, right? It's the data people's view. Organize everything up front in this way that seems to make perfect sense to you. And it's aesthetically appealing because everything has a place and there's a place for everything. And right, that's the fifth normal form data modeler's view of the world, which is the exact opposite of what a developer or even a user wants. Because, I want a book on data architecture. Well, there's blue ones and red ones. Which one do you want? That's not exactly the right answer. If you organize it wrong, then people can't find stuff. But in order to organize it right, you have to understand what they're using and what they're using it for and how, right? So if you look at the library example, it's organized based on frequency of use and ease of finding things, not preordained models that you've chosen.
This kind of reminds me, if I were to set up a library, I would organize it the way I think is proper, but you're saying nobody else thinks the way I think because I'm simply defective. So I've set it up wonderfully and nobody else could use it.
Right.
Okay. So what if I flip that and I think, okay, instead of looking at the data first, kind of looking at the next slide, what if I go start picking up the technologies? I look at all the cloud providers and they've got wonderful data technologies. What's wrong with that?
I think we're seeing that now. It's been generously speaking, since the market really, picked up, 10 years of we're going to jettison everything that we did for the prior 20 years, which was a result of the prior 20 years before that. And the prior 20 years before what we are getting away from now looked a lot like this, which was, I got new technology. What could I do with it? And we forget about the data completely. Right. The idea behind this is that the new technologies make things so easy and are so flexible that we don't worry about where we put stuff. So data lakes, which, came out of a notion that was completely different than they are now. The guy who coined the term did not think of a library. He thought of an encyclopedia, one big volume of one set of stuff, instead of this, but it's turned into, hey, what if we just dump all the random information in? We have smart indexing. We've got storage that can introspect this stuff. We have CPU in piles. We don't have to worry about being CPU constrained anymore. So, hey, you got all this great stuff. Search it, scan it, index it. We'll use the magic of AI and we'll build a catalog. And that's great for building a catalog, because now I know maybe what I have. Perhaps it's been labeled correctly because I've used the magic of knowledge graphs and artificial intelligence to construct my catalog. And the catalog still points to something. And that something is a hunk of data somewhere that you still have to find, access, and on the backside of secure and manage and make sure it doesn't escape if it's sensitive and so on. And so piling all the crap on the floor still means you got to search through and find the stuff. So it's not a system of managing the information. The technology is the shelves and the arrangement of shelves in a room and things like that, and how you get those things in there on a conveyor belt and dump them through a hole in the roof. But it's not the whole thing, right? These are components, aspects of architecture, and these focal points that we see are the two most common focal points in the market.
Okay, so you're saying they are important. I should know how to organize and I should care about the technology, but I shouldn't start with those.
Right.
Okay, so it sounds like there's a third thing, which goes back to it's made of people. So on the next slide,
Yes.
it sounds like that's the key.
That is the key. The key is that as an architect, as a designer, building data ecosystem, building your data architecture underneath that ecosystem, you don't want to focus on the data. You don't want to focus specifically on the technology. You start with the people, right? The old design cliche of begin with the end in mind. Well, the end in mind is Joe Blow asking a question, or me searching for a specific piece of information, or an application that is processing a bunch of data to predict what's going to happen next and position that in a mobile app or in SAP or something like that. And so you have to start with people and what they do. And that's analogous to the way a library is constructed. I like the library analogy because it's not aimed at one person or one group of people. It's aimed at all kinds of people. Like this floor plan, there's a children's area, there's a young adults area, and there's everything else. The interesting thing is they all contain books, they all have shelves, they all have the same sets of things, but they're oriented first around some groupings of library patrons, users. Mm-hmm. And they have an organizing principle that is at its topmost level, which people. The secondary level of organization outside the big circles there, because, and by the way, there's a third circle on there. It's the staff, it's the people who have to maintain the library. And if you don't build things for that, you're also missing a piece, but that's a small piece. What's happened in the tech world is that we have gone overboard catering to the whims of the operators and the developers and forgetting about the users. And so first it was a big data market, and then it was all this data lakey stuff, and it's the cloud. It's all catering to builders. That's like building a house inside out because it's easier for the bricklayers that way. And so there's a lot of attention that has to be spent on this organizational principle that's an overlay on your data architecture. And then underneath that, you've got a secondary layer of organization, which is, how did you organize the books in this library? Well, fiction, nonfiction, this, that, and then shelved and organized them. And so you have to know what's important based on the users, because there's library books that are in special collections. There's library books that have their own room. There are library books that are in references that are in the back, and you have to request them. They're not just out there for anybody. And so you're positioning information based on frequency of access, type of access, and the fact is that stuff changes over time. So catalogs point to information, but that stuff changes all the time. So cataloging isn't enough. The organizing principle that goes with that index has to happen. And this is all derived from people, how they use information, what they need, and how those needs evolve over time, which gets you to the library having study rooms media rooms, places for people to work, to spread out on a big space, places for noisy work, right? Closed rooms because people talk to each other, quiet rooms. And then, of course, the back room where things come in and things go out and stuff gets returned and fines are assessed and all the usual operations of a library.
And yeah, that would be me.
Same thing with us and data.
Okay, so you mentioned IT, and you mentioned, well, you didn't necessarily say IT, but I'll say IT. When we develop data architecture, if you kind of look on the next slide, many times the users are there and they're saying, I want self-service for this, and I'm trying to design something, and the users are saying, finished product. Now, how is that different? What do they mean by finished?
Right. I mean, the real question, just like that library example is, well, what do people say they want? And one of the things you learn if you do a lot of design work is what people say they want and what they need are actually two different things. And you have to ask enough people what they want and at a level of detail that is appropriate to get at what they really want, right? But what they want, they say self-service. And they think in terms of finished products. Self-service, to me, the typical business person, I got a question, I need the answer to that question. Or an application form, I need this hunk of data that says, yeah, this is a good credit risk or a bad credit risk, or whatever it might be. Self-service to a user is typically thought of in a very ambiguous way as an answer to my question without ever looking at what kind of question are you asking.
But if I'm IT, when you say self-service to me, I'm absolutely guilty of this. If you look on the next slide, I'm thinking, okay, I'm just going to give you tools. It's almost like the user says, I want someplace to live. And I say, well, here's some lumber and a hammer and some nails, go for it. Is that what we're doing?
It's what I call the dining on garbage model. You can make a meal out of anything, but that meal may not be very desirable, or the process to make it might not be that desirable, right? Ask anybody who's watched sausage being made. And so the idea that the technologist or the builder has of self-service is full of this sort of bias that people know more technology stuff than they do, and people should know more about that. We care about the tech, so should they. Well, they don't. They really couldn't give a crap. And so, to us, the tech people, and this is me early in my career too. Oh, self-service is just data access. Great. Here's a command line. Just type some SQL into it, or here's an interface, here's an API, or here's a storage bucket. Just point your tool at that bucket and scan it into your tool. Well, great. A cryptic string that points to an S3 bucket is not exactly right. And what the hell is a authorization token? And so the idea, the mental model that lives in a person's head behind this is users have to be self-reliant, and that's a lot different than self-service, right? Self-service is I push this button and I get this thing, and it's this thing that I want. Self-reliance is that I know all the different pieces to get that thing that I want, right? It's one step below self-service. And so the technology side of this confuses these two things a lot, doesn't look at it from the perspective of the different kinds of people and their activities.
And I think it's really hard for we'll call them the end users again, because we're developing technology at such a rapid clip.
Right.
That's old hat. Now we've got, S3 buckets or ADLS, and you're just going to have to learn that. Congratulations, here's a video, go watch it.
It's funny, I read something yesterday for somebody doing a talk on the latest, and they referred to a couple of different things as legacy data lake technologies. And I looked at a couple of the things they were referring to, and the last iteration of those was 5 years ago, right? So, it's taken people 2 years to stand up a Hadoop cluster, by which time the thing was obsolete. And, everybody's saying, no, move it over here. And so it's funny, the pace of technology drives things, and you have to look at that skeptically, I think. You have to
Yes.
ask, is this contributing to the problem the users have?
Mm-hmm. Do you ever suspect we might be doing technology for technology's sake, and does that affect the data architecture?
Yeah, because we're not doing architecture.
Mm-hmm.
That's the thing. We think we're doing architecture, and we're putting technology labels on box and wire diagrams. And as I can't remember who it was that I used to talk to all the time, used to say that all the hard work is in the lines that connect the boxes, right? The line has its own diagram. That's the problem when you think
Yes,
like technologist as opposed to an architect.
exactly. Now, if we look at the next slide, you've kind of mentioned the unmet need. And I'm kind of
Right.
curious what you mean by that.
But the example is like self-service, right? The user might say, I want self-service. I want access to my data. Just give me my data. And then, of course, you give them the garbage cans, and then they're like, what's this?
Garbage.
Well, that's what your data looks like. So there's a level in between just give me my data and what they think of as self-service, and you have to bridge that gap. The real question there is, what is it they need? What was the unmet need?
Mm-hmm.
And sometimes there's nothing wrong with the tools they have, whether it's Excel or a BI tool or Tableau or a Jupyter notebook, but it's that they need a thing and they have difficulty expressing it. And what you're giving them is, say, a data warehouse guy is something that takes 3 months to get cleaned up and in a way that they can deliver. Or as a data lake guy, it took you 3 minutes, but there's a mile yet to go for them. And so the real question is, how do you parameterize that need? And why was it a need to begin with? What was wrong with what you had before? So I usually like to try and probe a little bit on, okay, so what are you doing that you need this, that the things that are already out there aren't good enough for you? That why question is really important because it starts to uncover it. And then the second question is a turnabout onto the technology side. Why don't you have it? And you ask the user, well, grumble, 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 IT grumble, or grumble, 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 my vendor grumble. And when you ask those people, how come they don't have this?
Mm-hmm.
Sometimes you get a lot of mumbling. Sometimes you get, well, we didn't know that's what they meant, right? And so my favorite example, it's my go-to example all the time, is you locked the gates, and you're not giving people access to things. And the data warehousing world is an incredible success and a massive failure in equal parts. And you look at any industry survey and they say, hey, the failure rate's 50%, which is kind of amazing for something which is an architecture that's been around for 30 years, and yet people still fail to build the damn thing. How is it that they're failing to build something so well understood? Well, it's because they're not paying attention to the needs and the fact that what they're building doesn't meet the needs. And so let's throw all of that out and go the exact opposite direction. Instead of over-engineering, we'll under-engineer. And why was this happening? Well, the definition of a warehouse was a read-only repository. Oh, well, that's kind of a problem because my needs aren't read-only. Analysts need to shape data. And if you can't shape data because you got no place to put it, you take it out and you do it somewhere else, which is Excel or your desktop or whatever. It's a Tableau extract. That's fine.
Yes.
But your police line that said, hey, no, you can't do any of that stuff here is IT saying no. Why? Why did that happen? Well, you'll make a mistake. Well, our disk space is low. Why? Too many people make copies of stuff and we can't keep track of them and we've run out of space, and so it's a storage cost. And so we turned everything into cost of storage metrics and then unleashed first HDFS and then various filers and then things like Azure Blob Storage or Amazon S3 or whatever it might be. That's That was the solution. And so the right thing to look at is whenever you say, no, we can't do that, or no, you can't do that, your policy is the problem. Policies are about people's behaviors, and so that's the real crux of the issue. And whenever you say no, whenever the policy is trying to bend people to shape them to task, we built technology, you can't do your job in that technology, you make copies and extract them from that technology, we try to stop you from doing that, right? It's a war of escalation because you're constantly forbidding things. That's the fundamental problem, which is why we have this unmet need. And if you get to that, then you can start thinking, how might we fix it?
Mm-hmm. And so looking at the next slide, then you're very explicitly saying, what is the user trying to do? And perhaps if we just simply make it easier for them to do that, that actually might guide them in the right way.
Right. I mean, turning things around, sure, I love data warehouses, but I also hate them, and business intelligence was envisioned as an output-only mode where somebody thought of all of the questions to be asked, and if they're common questions, it's great. So the architecture is shaped for consumption, but it's not constructed around answering net new questions on net new information that may or may not be available easily. Mm-hmm. And so you're forcing a certain model, right? It's an architecture of control. The idea that is behind what people talk about as a data lake today, not the first two iterations, is an architecture of permissiveness. And so these are two different philosophies of how to guide people's behavior. One's a stick, and one is nothing. And you got to kind of use a little of both. You don't have doors all over buildings. You have doors in certain places to control access, and because doors are expensive to build into the framework of a large building and so on. And so you think about how you're going to do that. And in the idea of, fix policy first, well, number one, give people a place to work, damn it. Don't make them make copies. Like, I run into this all the time in data science. I pull the data into my Jupyter notebook. I don't have the local resources, so I need to put data somewhere else. So they give me a place to put it somewhere else, but I also don't have the processing capability locally to do that. So now my notebook has to hitch up to 5 other things, like PySpark, for example, or Dask. Most people on the user side want to go Dask. Most IT people want PySpark. Why? Better resume building. But Dask probably solves 90% of the user problem, but it's neither fish nor fowl. So how do I shove that into my architecture in a way that makes everything fit? Yes. That's what the architect should be doing, right? Listening to the user and the task they're trying to achieve and constraining the technologies to that. So shape the technology to meet the need. And in the data architecture space, some of this is about, well, how would I position the data for this or that, for Dask or for Jupyter or for whatever, so that there's minimal friction between what the people want to get done and that data.
Okay,
that's what we're talking about here.
Yeah, so guide them. So if you look at the next slide, I think that really kind of captures it, design and ask what is it they're trying to do. And it looks like you've got a couple of suggestions here.
This is just an example, right? This is just a laundry list of, okay, what do you mean, right? What do you mean by asking what they use? Because I hear this all the time talking to people trying to design things. It's analytics. Well, there's a lot of different kinds of analytics. What exactly do you mean? And if you ask a data scientist, they're very algorithmically and tool oriented. And if you ask a technology person, they're thinking a different way. And if you ask a user, totally different yet again. So what problem are you trying to solve? Well, I just need a factual answer to a factual question. You know what that is? That's an ad hoc query. Now, it may be that lots of people ask that. So tool pointing to data warehouse is the right answer. But if nobody's ever asked that simple factual question before, there may be a bunch of go to the source to get the data for that, right? So you have to understand the context of use and the information that they're using. And that pattern over time is what's important. And so every single one of these has a different workflow. That's the key.
Okay. So so data architecture is not just one thing. There is no true answer, so to speak.
It's a big picture. Yeah.
Got it. So, if I look at the next slide, how do I start understanding then, what data is going to be used?
Right. It's, the question then is, well, asking people about the workflow doesn't get at the data part of it, right? And one of the things that's missing in our data architectures, both old and new, is how the data gets used. If you look at data warehouses and data marts and all the different things people have built up, OLAP cubes, Power BI stuff, it's all doesn't really give you a picture of how the data is being used. Likewise, the data lakes and the Hadoop clusters and all the rest, I'm using Spark SQL over HDFS to do this thing. Nobody's keeping track of which data from which data set, which is the next level of organization, is used by which people. And what's the frequency of that use? And what's the frequency of combination of this thing with that thing? In a database, it would be joins, that data linked to that data. And all the different pictures of those joins form diagrams that look like this, which is ripped from one of the Teradata tools for looking at data usage to understand. And and what the picture tells you is there's a ton of data at the core, and there are a bunch of uses, the ellipses, the arcs, that show things being used with other things. And if you look at those, that tells you what you should be modeling or paying attention to versus leaving freeform. Catalogs don't tell you anything about this, right? Catalogs tell you what's there, nothing about use. So you've got to give people a place to work. Like I said before, if you're restricting that, you won't see it. That means you got to control it. If you control it, then you can monitor it. It's kind of like having a big backyard for the kids to play in. If you don't have a yard for the kids to play in, they're going to go play out in the street or somewhere else. You, number one, won't see what's going on. And number two, they'll, get tetanus playing in the junkyard or something.
Yeah, I like that. I once heard the story of a university that had set up, and before they built sidewalks, the president said, just let the students walk wherever, and after a year, you'll see the paths. That's where you put the sidewalks.
Yeah, that's the principle. It's a simple principle, been around for 1,000 years, but, there's a downside to that. You do have to pay attention because you're building a sidewalk, not a path. Otherwise you're just paving cow paths, and that may not be the best way to drive cars.
True enough.
Right.
So as I start getting a sense here, again, what I'm understanding is, data architecture is a process. I listen to the people, but then I'm going to have to maintain it. So this is not like a one and done kind of deal.
Right. I mean, the one thing that the tech industry in particular, our industry, is really good at is building new stuff. And a lot of us are or were programmers. And developers develop. That's what we're gold on. That's what we do. And we like to do it. The problem is that there's an operator on the other side, right? And, DevOps was about largely building web applications, right? So now you're hearing a bunch of people talk about data ops. And what's that? Well, it's not purely data management. The architecture dictates the things you've got to do. And if you're not paying attention to that, then the maintainability on the other side of this for the users becomes a time sink. And so one of the real interesting trade-offs between over control of data on one hand and complete free-for-all of data on the other hand is labor. I can run a very efficient environment with 3 people. And I know this because I've done it, but my response time to change is going to be really low. Or I can have a very flexible environment where I can build new things very quickly. But the trade-off there is the exact opposite. Every single thing is a new thing. Reuse is nearly zero. The ability to compose in that environment is not really architected into the environment. And so the composability on the one hand and the buildability on the other hand are attention that an architect has to respond to. And that is that attention to maintenance. That's why people are discovering now that entirely oppositional frameworks that have been dumped off in cloud take 4 times as many human resources to do, which is a tremendous cost to absorb and complexity downstream.
Very true. So as we kind of wrap up here, I know we ran a little bit over, but I think we're still okay. If we kind of look at the last one or the next slide, it's kind of okay. I'm going to have to focus on the data, and I'm going to have to focus on the users then. So it's almost kind of like I have to look out almost 180 degrees. True?
Right. Well, we're coming back to architecture, right? I mean, we're coming back to the fact that architecture is about people, and it's about the process of maintaining that architecture, which people tend to ignore, which the builders tend to ignore, I should say. The ever leaky roof of the Frank Lloyd Wright house, right? He never built a house that didn't leak. That was one of the big critiques of him. So there's the people side, and there's the process side of both constructing and maintaining and using that architecture. And then there's the technology side. And these are the 3 legs of what you're constructing and your design methods for how you're going to approach this, how you're going to architect it. And this picture is just a continuation of that last discussion, saying, look, it's not just the data, it's how that data is used. Because you will find that 70% of your data is used over and over and over again by largely a lot of the same people. 30% of the data is used by one person, one department. And yet, if you build an architecture that forces you to do 100% curation and management on everything, you're wasting a lot of time. So you got to relax the data warehousing side of things and the data management principles. The flip side of that is if you treat everything like that 30%, you're building a lot of labor into the system. And so it's, it's showing constraint. And so people and their use of information sits at the core of it. What they're doing with it and which information they're using. That's the starting point for all of this. And that's the part that's actually very hard to get. And we don't instrument our systems to get it. And so we're building new systems without any instrumentation and flying blind.
Yeah, it's easy to do it that way. So you're kind of telling us really, again, it's a hard message that data architecture is not just a magic bullet. It's not a shiny object. I got to think about the people, which kind of brings us back, really kind of to wrap up. It's Soylent Green. For those of us who don't know, clue us in.
So yeah, it's people. Right? When the oceans are dead because we've dumped all our crap into them, right? We've gone from data lake to data ocean. The only thing we've got left to make stuff out of is people. So, the real concluding kind of, picture here is that it's the human practices that matter. And in technology, we've gotten further and further or increased the distance between the people who are actually responsible for building and maintaining things and the people who are using things. People used to talk about the consumerization of IT. Well, cloud becomes the ultimate consumerization because any business user can swipe a credit card or set up an authorization with a cloud blanket agreement and use any service that's out there. Right? And that last slide is about curation, right? Curation of data, but also your curation of technology. And so if you look at that picture, it's actually the next slide. Is you've got to establish these practices. These are net new practices. They're not in the old world. They haven't been developed in the new world, and hardly anybody's talking about them. How do you curate? How do you curate books in a library? How do you curate, movies in a movie store of yesteryear? How do you curate what gets surfaced on YouTube or TikTok? There are human elements and automated elements in equal part. And the core to pay attention to is not the details of each individual thing, it's the overarching thing. So the data management professional pays attention to what's inside a data set. A data curator pays attention to the data set, not what's inside of it at a detailed level, not data models, data sets, right? So it's all about how do people use that stuff. And that's where we have to be paying a lot more attention. And we're so far from the users because they're using tools and we have no visibility because they use SageMaker. And SageMaker and Amazon depends on some Amazon storage technologies that are invisible to you. You can't monitor them unless you are the one putting the data into them for the user. So you have to build a hub and spoke architecture to deliver the data into that thing so you know what they're using, which means a self-service framework for how to request the data that goes into that thing for the data scientist. So you begin to see all the bits and pieces, and it all starts with that use.
Wow. I know we're kind of a little bit over, but I do have one or two questions that have come in if you're okay to kind of continue.
Okay, go ahead.
All right. So one of them is, can you explain a little bit more between the self-service from the user and the IT point of view? Maybe do you have like an example or a kind of a story about that?
Yeah, so, self-service from the user view is, classic analyst question of, well, just give me my data. I just want access to my data. And so the question is, okay, well, if you don't really interrogate that use, you end up doing something which we used to see when I was running statistics and machine learning teams 2 decades ago. And that was, I have a bunch of people using statistical analysis tools, and data mining tools. And the process of doing that work is a process of iteration over data, because you take raw data, you learn and understand what's in and not in that data set. I mean, this is the essential data science process. Mm-hmm. And then you realize, well, this has some data problems or some anomalies, or it needs some cleanup, but I'm going to use this. I'm not going to use that. And so you go through and you say, well, I'm going to use this technique, which requires me to shape the data into this shape so that it matches up. And if you do that, then, that's the process. So your self-service is get information. Oh, that's not exactly the information I needed. I needed some different information. So now I need that. And what would happen with the data team that was responsible for provisioning the data infrastructure is they go from request, 3 days response, request, 3 days response. Well, as the analyst, my request is in the workflow I have. It's immediate. And so I, the user, the analyst, am complaining about the response time of IT. The IT guy is saying, why don't you just tell me that in the first place? After the third question, they take the entire data set, denormalize it into a table of 800 columns, dump it into a CSV, and give that to them. This was 20 years ago. Guess what we're doing today? Exactly the same thing, right? Build me a pipeline. Build me another pipeline. Build me another pipeline. Finally, the pipeline developer says, screw this. Here's 800 columns. I'm dumping it into a Parquet table in S3 or into the Azure Blob Store or whatever it is, so that you can use your thing and do your stuff. And now I've got an 800 column table to maintain, or I just did that work and dumped it. So yeah, cost of storage is cheap. Do that times 20 because you got 20 different data scientists. You're not solving the problem, right? You've defined the problem in such a way that you're solving what you thought the problem was and what the user thought the problem was, and you're talking past each other, right? Yeah. That's the problem we're talking about right there.
Yep. Okay, maybe a last question then is, all right, so what is IT's role then in data architecture? Because frankly, we've kind of trashed IT. So where do they fit?
Yeah, this is a tough one because it's the role of an architect. And for 20 plus years now, we have seen a diminishing emphasis on design and architecture because doing work up front was viewed as the obstacle because it smells like waterfall development. And if it smells like waterfall development, I don't want to go anywhere near it, right? And when you look at things Gosh, I remember working with Kent Beck years and years ago on XP and extreme programming, which was one of the precursors of Agile, right? Before XP, back in the late 70s, early 80s, we talked about stuff, and there's stuff in the research called risk-based software development. Instead of prioritizing things based on requirements or function points or whatever, you find the areas you know the least about that carry the most risk, and you prioritize development cycles in a spiral model. It was called the spiral model of software development, right? And that spiral model is based on risks and building things to that, which is very similar to an agile, or what has been recast as DevOps model of, we don't know exactly, and we cannot ask the users exactly what they mean. So we're going to do fast prototyping in a DevOps framework, which is a code framework, an architectural framework for quick release of features tied to the tool chain that allows you the quick release of features. And so the role of the architect had shifted somewhat from architecting the application to assuming my application framework's okay, and architecting the tool chain and the process the developers use. Right? It's an interesting juxtaposition. The challenge being that in analytics, the end user and their use really, really matters, because they use different tools for different reasons. And we, the IT architects, should be paying attention to those tool chains and how they get orchestrated, 50% of which is data flow between those tools. So IT's role is still front and center, architect and design, but the emphasis isn't the end product of design it was in business intelligence or a recommendation engine, which was the other stuff I was working on 15, 20 years ago. And building a rec engine or a predictor and shoving it into an application has a very tight framework around it. But both of those things exist as needs in an enterprise. The real question is, how do you step back and look at that bigger data picture and lay out the data architecture and the tooling to support both of those and the other 20 questions?
So, Mark, you've kind of given us a hard thing to think about, that data architecture is not just the tool of the day. It's not just, is it integer? Is it decimal? It's the people, and where do they want to go? And whatever it is, it's going to change.
Right. Fundamentally, you've got to keep that in the design process, in your requirements process, in your operations.
Well, Mark, this has been an excellent episode. You've absolutely enlightened me, and I certainly do appreciate that. Again, shout out to all of our audience here. If you want to reach out to Mark, Mark, what's your contact? Do you want them to contact, or do you want to go into the dark and hide?
I like hiding, but you can ping me on LinkedIn. You can ping me on Twitter. You can drop me email. It all works. I'm always happy to talk.
Excellent. Okay, everyone, thank you very much for attending. As always, we'll have another one of these in about a month. Look for that advertisement. Until then, enjoy the holiday, stay safe, and we'll see you soon.
Thanks, Kevin.
Thank you.